Hello, myself Dr. Reha Rakhulia, MCH in Reproductive Medicine and Surgery. Today, I'll discuss about Cairo Consensus. Okay. We'll talk about Cairo Consensus. It is an RBMO article. Okay. Introduction. It talks about regulation and licensing of IVF lab. It was held in Egypt in 2017. Goal. What was the goal of this consensus? Three goals were there. First, to establish technical and operational requirement for air quality in IVF center. What is technical requirement? Technical requirement means like to install system such as HVAC, to install other equipment like incubators, and about infrastructure, how the IVF lab should be made, infrastructure. Then operational, this was technical. Operational requirement means everyday practice to maintain what we do in everyday practice to maintain air quality. That comes in operational requirement. Like cleaning practice. What cleaning practices are we? We use safe cleaning agent with low VOCs. Okay. Airflow management, temperature control, how we are making temperature stable, infection control. Okay. Now, second is to make a benchmark, that set a benchmark for existing laboratory, like KPIs. There are benchmark. No, this should happen, this much should be this percentage, like that. Third is to provide guidelines for construction of new existing IVF lab. It will create a aspirational benchmark, and it will set a new guideline for new art laboratories, guideline for construction of new art laboratory. Then second slide. What are the challenges with current regulation? What are the challenges is in current regulation, we art lab and surgical lab was considered equivalent, but they are not, because art lab has their unique features. Okay, so in art lab there should be minimal physiochemical stress. What is physiochemical stress? It consists of two things. First physical, then chemical. What are the physical stresses? Like temperature, physical stress, airflow, humidity. Chemical stresses like pH level. Okay. And chemical exposure like VOCs. These stresses should be minimal in art laboratories. Focus area and safe practices. First is HVAC system was designed. HVAC system is heating, ventilation, air conditioning system. Okay? For IVF lab, this was designed. Second is control of particles, okay, microorganism and VOCs. Third is selection of construction material. What kind of construction material? First, which has low VOCs, and low contaminants, which will produce low VOCs and low contaminants. Okay. Now, third हो गया. Fourth is safe cleaning practices. I've already told you what are safe cleaning practices. Safe clean, like using cleaning agent with minimal VOCs. Fifth is operational practices to optimize air quality, balancing temperature control and airflow. What will operational practices means day-to-day life, what we do in the IVF lab to optimize air quality, temperature, and airflow, quality and flow and temperature. Then infection control. So infection control will use measures to reduce VOC. Okay, we'll see about cold sterilization. There should be, during cold sterilization, there should be fewer or minimal VOCs. Then surface cleaner. This should be surface cleaner should also be with minimal or no VOCs. Hand sanitizer. See, basically, hand sanitizers are made up of alcohol. These are alcohol based. Hand sanitizers. So it contain either ethanol or isopropyl alcohol. It will produce VOC like aldehyde and formaldehyde. So in IVF lab, we don't use alcohol-based hand sanitizer, okay? But we'll have to use, we'll have to choose non-toxic, low VOC hand sanitizer, okay? How the laboratory environment affects gamete and embryo biology. Biology of gametes and embryo. Will lead to IVF success. So lab design, HVAC system, heat, ventilation, air conditioning system, and incubator equipment like incubators. These all should align with the biology of gametes and embryo. This all should align, with the support the biology of embryo and gametes. Means if embryo and gamete want pH of some 7.2 or something, it should provide these HVAC lab design equipment should provide that much of temperature, that much of pH, that much of CO2. Then this will, and primary goal is, what is the primary goal? Primary goal is to protect the gametes and embryo from the adverse external factors. If there will be stress, what will be affected? Stress will be there. What will be affected? Embryonic gene expression. Gene expression. What is gene expression? What is gene expression? Gene expressions are the, we may say these are the instructions present, okay, which tells cell what to do. Gene expression is instruction, kind of an instruction which tells cells what to do. This you'll have to do, this you'll have to do, okay. Second is gene. What is gene regulation? how well these instructions are controlled. Example, cell might not follow instruction correctly. I might give instruction correctly. Do this. Please clean the fridge. This is what instruction I'm giving. But I'm giving this instruction to somebody, and that person is not doing the work properly. Okay, so gene expression is the instruction which I'm giving. Gene regulation is the if that instruction is followed correctly or not. That is gene regulation. Then second is gene expression. Imprinting. What is imprinting? See, there are some genes which either come from mother or father. Means if mother's gene might get activated and father's gene might not get activated, or vice versa. One gene is switched off. That is called imprinting. Okay. Third is epigenetic. Epigenetic means gene are same, but these are read differently. Okay. Gene is same, but epigenetic does not change genes, but that gene is read differently in epigenetic. All these stresses are inherited. Are you getting me? All this adaptation to stress affect embryo gene expression, imprinting, and epigenetics inheritance. All this may be inherited. Then factors affecting IVF outcome. What factors affecting IVF outcome? First, biology. Patient biology tells about the quality of gamete. Like age less hogi, to quality will be better. Okay. Second is clinical factor. Clinical factor like stimulation. Clinical factor like stimulation. Then oocyte retrieval techniques. Then embryo transfer techniques. Then luteal phase support. What luteal phase supports are we using? This all will affect the IVF outcome. Then laboratory environment. Third is lab environment. In lab environment, the equipment. What incubator are you using? Contact material like plastic material, dishes we use, test tube we use. These are called contact material. Then methodology. What method are we using? Methodology. Then staff. These all factors affect the IVF outcome. Okay. Environmental factors. Lab factor we have done. Environmental factors. Micro scale and macro scale. In micro scales are temperature control, oxygen control, CO2 control, pH balance, which affect the embryo development. Macro scale, lab design, air quality significantly, air quality, lab design and air quality. This will influence the outcome. See, regular equipment maintenance, incubator and all. Okay. Maintenance, verified calibration. What is calibration? It is checking equipment. Calibration means checking equipment to ensure it gives a reliable result. To ensure it gives a reliable result. Like, see, this is incubator. Now it is showing 37 degree. Is it really 37 degree? To check that. Okay, it is showing 37 degree. This incubator is showing 37. Is it really This is called, then we'll apply calibration, okay? And preventing malfunction are the essentials. See, this is incubator. This is incubator. This is digital thermometer. Can you see here? This is digital thermometer. So it will check for the calibration in the incubator. Calibration in the incubator. Then contact material and methodology. What are the contact materials? Like culture media, plasticware, gases, all that comes in the contact of embryo, zygote, oocyte, that are contact material, gases. ICSI microtool. What are ICSI microtool? Like holding pipette, injectable pipette, OPU needle, OPU needle. These are all contact material, EEG catheter. All influence, these all contact material influences the embryo viability. Okay. Oocyte retrieval and handling is stable. Stable temperature. During oocyte retrieval and handling, there should be stable temperature. Like you must have seen that during OPU, like this is the patient, my drawing is not that good. This is patient leg. Okay, we are doing OPU. We are doing OPU here. Then there is one heating block. Heating block is there where test tubes are kept. This heating block, it maintains the temperature of 37 degrees Celsius. When we have to aspirate the follicle, we'll give this heating block, this test tube, okay, this test tube, and we'll put it in the OPU set. And then this will be given by the window in the lab area where embryologist is working. Okay. And there, the embryologist will see this embryo in a laminar flow. In a laminar flow, there also in the laminar flow, 37-degree temperature is maintained. Okay, so basically, temperature should be stable. Temperature should be stable, even stable temperature. During follicular aspiration, transport handling is a proper technical approach and adherent to standard procedure ensures optimal outcome. If we'll adhere to standard procedure, that will optimize our outcome. Impact of temperature and gases. Now, stable temperature, maintaining stable temperature during follicular aspiration, transport, exsurge, cumulus oocyte handling is crucial for, I have already explained this. Gas equilibration for oocyte and embryo, gas equilibration for oocyte and embryo. Now, stable PCO2. See, what is there is, see, we need to, we need stable PCO2. So, PCO2, O2, these should be stable. Like O2 is preferred less than 5%. Okay. If these are stable, then this will protect. Stable PCO2 is required for bicarbonate buffer medium pH equilibration. Because of stable PCO2, pH will be maintained. Bicarbonate buffer medium pH equilibrium while reducing PO2 protects again, and this O2 reducing will protect against oxidative stress. Now, what is there is, there are three type of IVF media which we are using. We are using three type of IVF media. GMOPs, GIVF, and GXTL. These media we are using. This GMOPs we use outside the incubator also. We can use outside the incubator. But the because why we can use, because MOPS act as deuterion buffered media with sufficient bicarbonate. So even if it is outside, it will maintain the pH. GMOPS media will maintain the pH, even hippies or GMOPS we use outside. Even if it is outside the incubator, it will maintain the pH. pH. It can be used outside the incubator. That is, it is telling deuteric buffered media with sufficient bicarbonate should be used to support embryo metabolism when handled under air, means outside the incubator. See, GX MOPS, they have shown G MOPS. For use after equilibration at 37 degrees Celsius. Overnight, we do equilibration at 37 degrees Celsius. MOFs buffered media containing human serum albumin. What is there is MOF buffered media contain human serum HSA, human serum albumin, gentamicin, and nowadays these are containing, because it is plus, no? Gentamicin and antioxidant. 3 antioxidants basically it contains. Okay, and it is for handling and manipulation oocyte and embryo in ambient atmosphere. I mean outside the incubator, if we are handling the embryos, we'll use GMOPS. Yeah, GMOPS plus. Okay, three antioxidants. What it is? ALC, ALA and NAC. Okay, ALC is acetyl L-carnitine. Then ALA is alpha lipoic acid, and then NAC is N-acetyl L-cysteine. This is highly beneficial for embryo development when used in combination. See, this I have shown that in the laboratory, in the operating area, we are using heating warmer, test tube warmer. Then this is the window. Then this is the window. We'll transfer from the test tube warmer. We'll give for follicle aspiration. Then we'll pass it through window. Then here in the focused area, in the laminar flow, there will be 37 degrees Celsius and there will be screening for oocyte. Okay. Impact of microenvironment changes. Even small changes in microenvironment affects the oocyte metabolism. Okay. Now we saw a mouse oocyte we saw, and we saw that even 5-minute exposure without amino acid, there was decreased blastocyst formation and number of cell, even decreased number of cell in blastocyst. Okay. Then protection of gametes and embryo from toxic substances. Pehla toxic substances, VOCs and airborne chemical. This can harm the gametes and embryo. Then second is, there should be safe design. Safe design. Non-toxic building material should be there. Like what building material? Like paint, adhesives, sealants, all this should be non-toxic building material. Then workstation and incubator. Like workstation, like up and incubators, like laminar flow, etc., laminar airflow. These should be select system that protect from harmful exposure. These systems should be selected. Okay, like workstation, like laminar airflow and other workstation, inverted microscope and incubators. These will protect the embryo from harmful exposures. Then gas supply. We'll have to use purified gas and well-designed gas supply. See, the person will take gas from, can give us industrial gas also, but we'll have to tell that person that no, want this for IVF lab and we want medically graded gases, pure gases. Okay. So, like industrial gases, we don't need. We want pure gases because industrial gases will release more VOCs. That is impure gas. We don't want that. Then okay, potential air quality issue. What are the potential air quality issue? Like construction material, as discussed before. If paint, sealants, and adhesives are in increasing VOCs, then we cannot use those kind of paint, adhesive, and sealants. HVAC air quality system should be good. Then cleaning product and air fresheners we should be VOCs free. VOC from lab equipment should be minimum. Human contaminants, cosmetic, hair. Like in IVF lab, we are not allowed to enter with lipstick on, with kajal on, like that. We are not allowed to enter. We should be uh, makeup free. Okay. Cosmetics, hair, skin cells, clothing fibers, like even clothing fibers, we choose some clothing fiber, laundry products, sanitation for infection control. All this should be for IVF. These are specified. Okay, for IVF lab, art lab, these are specified. You cannot just go like that. Clothing fibers which don't shed much, that clothing fibers are used. Sanitizer, alcohol-based sanitizer, we cannot use. Evidence in clinic. Okay, now we talk about Harper model. Harper model. First is hypothesis-driven research. Hypothesis-driven research will form a clear hypothesis, will develop a research question. Will this new filtration system reduce VOC? Okay, like that. We'll develop a clear hypothesis, a clear question. Then testing in animal model. We'll test in animal model, then donated embryo, then small scale clinical investigation, then larger clinical trials, then assessment of clinical and cost effectiveness. We'll see whether the cost of technology is justifying its benefit. Okay, maybe cost is in crores and it is not justifying the benefit, that much of benefit. So we won't use that system, no? Okay. Now, the HVAC system and clean room standards. Three things are there. Historical feature of art, laboratory, and design. We'll talk about how previously art facilities were there, then how it changes from time. Okay. Then design philosophy for new art laboratory suit. What we have to do for new art, if we'll make a new art lab, what all we have to do, what all design we have to do. Then physical isolation, how will you isolate art lab from other surroundings? Retrofitting existing laboratory suit, how will fit like with the art laboratory which are already existing, how can we make them good? This now historical feature of art laboratory design pre 2000s. Lab design like surgical suits or medical office without consideration for cell culture needs. Common design issues. What were the issue? It was designed as surgical suits, like surgical room only. Okay, but art lab has its unique features. There should be minimal physiochemical stress. Okay, art cannot be like surgical suits. Okay, it has a unique demands. So what was the issues? They were using vinyl flooring. Vinyl flooring will emit VOC. Second is they were using vinyl flooring. Okay, this will emit VOCs. Then they were using MDF. MDF is medium density fiberboard. Okay, minimum density fiberboard. This will also we make cabinets and cabinets with this medium density fiberboard. This will also emit VOCs. Then we cannot share this. We cannot share the HVAC system. We cannot share the HVAC system of IVF lab with other room. that for no air handling system or dedicated gas room supply. There should be a separate gas room supply and air handling system, separate air handling system for IVF lab. Cryopreservation, uh, what is this? Cryopreservation area without proper flooring protection. Okay, even where we use nitrogen gas cylinder, that was not protected. Their floor was not, without proper floor protection, their floor was not protected. So what will happen? Dent or will happen, or some gas will get released and destroy the floor. The floor can become slippery. And slippery, and dent can be there, so it won't be able to maintain temperature also. It can the when we'll clean it, it won't clean properly, so it could compromise the overall cleanliness and sterility of the IVF lab. Okay, no entry vestibule airlocks. Okay, no airlocks means, see, what are the entry vestibules is, this is the door, by, and this is another door. This is called vestibule. One person will enter from this door, they will close this door, and then they'll enter this door. So there will be less contamination. This is called vestibule. The area where the empty area, this is called vestibule. IVF lab separated by hallway. Then introduction of air showers and ultra low particulate filtration towards the late 1990s. Then they in 1990s, late 1990s, they introduced the air shower. What was air showers? These are used in chemical industries. Like, the person will stand here and air will come from upside, and it will go downwards, and it will remove dust particles and etc. That are called air showers. These are used in industries. And ultra low filtration, this is like a HEPA to remove particulate matter. Ultra. So these two were introduced in 1990s. Then improvement in art lab design post 2000. After 2000, what was the improvement? First is introduction of HEPA filter. HEPA filter was introduced. Then laminar flow hood was introduced. Then positive pressure system was introduced. These three were introduced. Right? And another thing is segmentation was done. What segmentation? Segmentation was done. Like cultural suit, where we culture. That was a different room. Diagnostic andrology room was the different room. Then gas storage room was different room. Huh? What all we improved? What all improved was air handling unit was improved, and there was dedicated air duct, which was not shared by other room. Dedicated air duct to IVF lab. So clean filtered air. There was no sharing to other room. Clean filtered air will come from that place. Huh? AIA guideline for art laboratory. AIA is American Institute for Architect Department of Health and Human Service guideline. So what they did was, they like surgical room only, they considered IVF like surgical room only. But IVF is not like surgical room. It has its unique demands. It has its unique features and demands, okay? Which first is most stringent standards based on surgical room. What was followed according to AIA? What was followed is positive pressure. Okay, positive pressure, air movement. Second was 15 air changes per hour. That too, in that 3 were fresh air changes. 3 fresh air changes, 15 air changes per hour. Third is no recirculation in no window ACs. That will bring contamination, no? So there was no window AC. Temperature was considered to be 2023. This was according to AIA. This is not followed now. I'm talking about history. This was according to AIA. It is not followed now. Fifth is humidity 30 to 60% was considered, because what will happen in low humidity, there will be eye irritation, there will be static electricity, like any you'll touch the surface and electric charge that build up on surface of objects, that is called static electricity, will touch the surface, zing karke. There will be electricity. And if humidity will be high, then what will happen? Mold growth will be there. Current guideline and changes. Europe and Asia focus on particle removal, but recognize this alone is not sufficient. Currently, what we are using, this is according to AIA. I'll talk about current standard later. This is according to AIA. I'm talking about history right now. First is focus on particle. Now, current guideline focus on particle removal, but currently we know that this alone is insufficient. We'll have to take another measures also. This alone is insufficient. Then segmented lab design. I've already discussed now that 2000 post 2000 there was segmentation of lab. Now currently also there is segmentation of lab. Segmentation of lab, like andrology lab is different, endocrinology lab is different, culture suits different, gas room different, entry vestibules are present. Entry vestibules, again I'm telling, and what are entry vestibules? These are there, like this door, then there will be vestibule, nothing will be there, and this door. Okay, this is called vestibule. Yeah, person will come, this will open this door, that this person will open this door, and when this door will close, the person will open this door. Okay. And then third is air quality control. There will be HEPA filtration, dedicated AHU, chemical filtration. Chemical filtration will be there. Chemical filtration, what? Carbon filtration, potassium permanganate filtration. Okay, positive pressure, and there will be positive pressure system to prevent contamination from the outside air. Common design and operating issue in IVF lab. And what were the issue? First is incomplete isolation. The IVF lab was not completely isolated from other room. Second is inadequate positive pressure. We were unable to maintain the positive pressure. We are sometimes unable to maintain the positive pressure. Then chemical filtration issue. Incorrect filter media. Activated charcoal alone. See, activated charcoal alone, we don't use. We use charcoal plus KMNO4. KMNO4, potassium permanganate. Charcoal plus potassium permanganate. Charcoal plus potassium KMNO4. Potassium permanganate. Why? Because potassium permanganate is a strong oxidizing agent. It's a strong oxidizing agent. So it will neutralizes and break down the VOCs. Okay. So we use a charcoal filter with the activated charcoal filter with the potassium permanganate filter. Alone we won't use. Incomplete oxidation of VOCs by photochemical system. What is photochemical system? Photochemical system is when UV light plus oxidizing agent is used. UV light and oxidizing agent is used to break down VOCs. Okay, this is called photochemical system. So there is incomplete oxidation. When there is incomplete oxidation, there is issue. This is the issue, that sometimes there is incomplete oxidation. Failure to maintain and monitor and maintain filtration system. Okay, inappropriate construction material. Sometimes we use inappropriate construction material. I've already talked about MDF. MDF is medium density fiberboard. Medium density fiberboard. We cannot use. We cannot use vinyl flooring also. We don't use. We cannot use linoleum flooring also. We cannot use linoleum flooring. We cannot use oil coated duct work. We cannot use oil coated duct work. We cannot use formaldehyde urea insulation. Formaldehyde urea insulations in like if we'll talk previously, we used to take formaldehyde urea and we used to insert it between the balls for insulation. Okay, but in IVF lab we cannot do that because there will be off gassing of formaldehyde with that. Okay, and formaldehyde is not, it's a VOC, it is not at all good for gametes and embryo. So we want to do formaldehyde urea insulation. Then low fresh air ventilation rate. Sometimes fresh air ventilation rate is very less, which is not good. Then low fresh HVAC system bypass. Sometimes due to why will it, due to poor design. Air can bypass filters due to poor pressure monitoring or lack of proper maintenance. Sometimes HVAC system can get blocked if it is not properly maintained. Its efficacy can be minimized if it is not properly maintained. Compromised air intake. Air intake placed in contamination areas such as, okay, sometimes what we compromised air intake means sometimes air coming to the IVF lab can be from the shipping dock area. What is shipping dock area? Shipping dock area is where goods are loaded and unloaded from the truck. So there will be so much of population. If air comes from that area, then it is a problem. Okay, it is a problem because that air is highly contaminated. Then difficult maintenance, poor design. Example, AHU or chemical filter placed in the ceiling. Now, if we'll place AHU, air handling unit, and chemical filtration in the ceiling, if we'll use, there is difficulty in maintaining. Who will maintain if it is in ceiling? It's difficult to reach there, है ना? So it should be, if it's placed in ceiling, there will be difficulty in maintenance. Inadequate humidity control. Sometimes in IVF lab, we are unable to make a adequate humidity control, which is also a very detrimental thing to embryo and gametes. This is formaldehyde foam insulation. It was used previously. Okay, now not used. Now not used because there will be off gassing of formaldehyde from this. We don't use this. I've just see this is foam. Oh, these are used for insulation. In between the wall, we used to keep this. Design philosophy for a new art laboratory suit. A step in creating optimized modern lab design is to define function of the room. First is retrieval room. Okay. Second is transfer room. Retrieval room, oocyte retrieval, where there will be oocyte retrieval. Second is transfer room. Embryo transfer will be there in the transfer room. Third is IVF culture and biopsy lab. Okay, lab, embryo culture, where culture will take place, and biopsy lab. Fourth is cryopreservation space attached to the suit. Okay, cryo space attached to the suit. These are the room which we will have to define for the art laboratory suit. Then another is we'll have to use double door pass-through window. Double door pass-through window means there will be two doors in the window. There will be two doors in the window. Okay. There will be two doors in the window. This door will open. It will be closed. When we'll keep whatever we'll have to pass, we'll keep it here. And then this will be closed and this will open. So that there won't be any air leak and the positive pressure is maintained inside the laboratory. Then third is hard lid sealing. In surgical and clinical room, to control the air leak, we need hard lid sealing. Sealing means ceiling, okay? Like opposite of floor. This is floor, this is the room, this is floor, this is ceiling. Ceiling will be hard lid sealing so that there won't be any spaces to air leak. Then separation of the dirty room. Separation of the dirty room means there will be separate room for gas cylinder room. For gas cylinder, there will be separate room. Okay. Then for storage room, there will be separate storage room. Storage room. Then there will be staining room. Fixation and staining room will be separate. Okay. Then there will be and diagnostic andrology and diagnostic andrology and endocrine assay lab will be separate. Okay. Then there will be janitor closet. What is janitor closet? Janitor closet is it holds all the supplies needed to clean the building. Okay. Janitor closet it supplies needed to clean the building or the suit, that is called janitor closet. Then cryo bank. All this dirty room will be separated from the art suit. Okay. Now next is art suit clean environment key measurement. First is control outside infiltration. We'll have to control outside infiltration. Control outside infiltration. How? We'll control. We'll use first of all. First is we'll use doors. Doors which has vestibule or staged interlock door. Vestibules or staged interlocking doors. What is this vestibule and staged interlocking doors? Means, see, this is the door. There will be a space. This will be the another door, and this is the vestibule. That is empty space. Okay. So when this door will be closed, this will open, and this will open, this will close, so that air inside the air pressure inside the lab will be maintained, and this vestibule is a empty space. Okay. So dirt will not go inside the art lab directly. Then second is lightning. Lightning should be on the ceiling, not in the ceiling. What is this? On the ceiling, in the ceiling? See, it should not be inside. It should be on the ceiling. Like, it should not be inside. It should be on the ceiling, so that there won't, so that there will be, first of all, easier maintenance. There will be easier maintenance. Second is better airflow control. There will be better airflow control. There won't be any leakage of air and something. And there will be decreased contamination. Decreased contamination because there will be less embedded space and fewer area where dust and contamination can accumulate. Okay. So three things. Lightning should be on the ceiling, not in the ceiling. Lightning should be on the ceiling, not in the ceiling. Then third is gasketed access panel and sealed with silicone. Access panel, gasketed access panel. Gasketed, what is this? Gasket is, what is gasket? Gasket is a flexible rubber like seal. We see in the refrigerator, no? There is gasket. This is flexible. I'll show the diagram right now. Flexible rubber like seal that fits the gap to create the airtight or watertight barrier. It will create the airtight or watertight barrier. Okay. Access panel. What is access panel? Panel or door that allow access to the area behind walls. Means if there is some panel, access panel, we'll use gasketed access panel. Okay. There will be airtight and watertight barriers in that area. And for maintenance, and if there is some panel for maintenance and inspection, that will be gasketed. That access panel will be gasketed, and it will be sealed closely, tightly, to prevent air, moisture, or contaminant from passing through. Okay. Sealed with silicone. Gasketed access panel sealed with silicone. Reseal access panel after opening. If we open, by chance we want to do something, we want to open this access panel, we'll have to reseal the open access panel. Whatever will, okay, we'll have to reseal the access panel. Then pressure monitoring, maintain positive pressure. Pressure monitoring is we'll have to maintain the positive pressure and measure routinely. We'll have to, the pressure will have to measure routinely, and we'll have to maintain positive pressure. The ductwork and AHU component. In duct works and air handling unit, we don't have to use anti-rust. We don't have to, rust inhibitors we cannot use, okay, because that rust inhibitors are the source of VOCs. We cannot use rust inhibitors because these are the source of VOCs. So in the duct, in the air handling units or duct work, we cannot use anti-rust or rust inhibitors. This is, see, this is the interlocking door, what I was talking about. Interlocking door system uses vestibule interlocking. If this door is open, this will get closed. If this is open, this will get closed. Okay, and this is the area, vestibule area. Vestibule area means empty area. Okay, this is the empty area. Between two doors, there is an empty area between the secure area and the unsecured area. This was unsecured area and this was secured area, with a lockable door between each area and the vestibule. Okay. Then this is gasket. This is gasket. I was telling you, na, in refrigerators, fridge also. So not fridge, we use, we see these type of rubber gasket. Okay. And this is silicone sealant. We use silicone sealant for sealing the access panel. Then gas and ventilation management. Separate room is used for compressed gases and liquid nitrogen. For compressed gases, we'll use separate room, and for liquid nitrogen, we use separate room. Now, gas room has to have extra protection. Make sure gas line are sealed with extra protection where they pass through the walls to prevent any leak, because we don't want leak. Okay, so there should be extra protection in gas outlet. Fire protection regulation. Now, see, if what are dampers, dampers are, if like these are two rooms, okay. Now there is duct. Like if in this room there is fire, dampers will close automatically. From the in this duct, dampers will close automatically so that fire from the duct do not goes into another room. Okay, like this is air duct and fire is in this room, so dampers will close automatically so that fire from this room does not enter another room. Okay. Mhm. uh, but IVF is a closed space. Okay, IVF lab is a closed space. There no window, nothing is there. So if we use dampers in it, sometimes dampers can get closed automatically. If dampers can automatically closes, there will be risk of anoxia and CO2 intoxication. There will be risk of anoxia and CO2 intoxication, because there won't be any alternate air supply in IVF lab. It is a closed lab and a closed chamber. So we cannot use dampers in IVF lab. Okay. See, this is the damper. This smoke is going here, and this smoke or fire smoke, this will get closed. Okay, this will get closed so that smoke or the fire cannot pass through the duct into another room. Same like this also. See, here is fire and this is the damper. This is the damper, and it gets closed. This damper gets closed so that from this room fire does not goes to another room. Okay. Then physical isolation criteria. Physical isolation criteria. See, sealed barrier will be there. Sealed barrier in the wall, door, and ceiling. Secured sealed barrier, walls, doors, ceiling, and high positive pressure to prevent contaminants. In wall, doors and ceilings, there will be secured sealed barrier, so that there will be the IVF lab is isolated from the other labs. And high positive pressure to prevent contaminants. There will be high positive pressure to prevent contaminants. Now, what is SF6 used for? SF6 infiltration. What we'll do is, uh, will in outside the lab, will SF6 is to check if lab is properly sealed by releasing gas outside and seeing if it leaks in. Okay, outside the lab, if this is lab, outside the lab, we'll leak SF6, and inside we'll check if SF6 is leaking or not. If it's not leaking, that means IVF lab is properly sealed. Now, retrofitting existing laboratory suit. What does that mean? Retrofitting existing laboratory suit means already existing lab suit, what we'll do for that laboratory, which is already existing. Okay. Common strategy to improve existing labs. क्या है? First, boost fan. We can install boost fan. This can create positive pressure. Okay, boost fan. Second, we can use double door pass through. I have already talked about double door pass through. Then third, will decrease new material in lab. Fourth, supplementary air cleaning system to lower particulates. We can use some other supplementary air cleaning system to lower the particulates. Now, controlling VOCs, the fabric of the laboratory, measuring VOCs and aldehyde and source of aldehyde in art laboratory setting. We'll read this in two subheadings. Okay, controlling VOCs, we'll read it in two headings. What are VOCs? What are VOCs? These are organic chemicals. Evaporate at room temperature, which evaporate at room temperature. What is the source of the VOC? Source of the VOCs is outgassing from the lab material, like furniture and consumables. And other is gases used in incubators. Gases also sometimes emits VOCs. Then contaminants like culture media and mineral oils can also emit VOCs. How VOCs spread? VOCs can move from different media, between different media, like from oil to water, they can move. Okay. This movement depends on the concentration, temperature, and pressure. This movement of VOC depend on the concentration of the VOCs, temperature, and pressure. What is sink effect? Sink effect is, like example, water is there. If this water is acting like a reservoir for absorbing VOCs from another medium, like air. This is air, this is water. If water absorbs VOCs from the environment, from the another medium, means air, then it acts, that means water is acting as a sink. Okay, because it is absorbing the VOC. So that is sink effect. Non-toxic VOCs example. See, there are some non-toxic VOCs that are the non-toxic VOCs is silicon that is found in gasket and tubing. This is gasket and tubing. This is non-reactive VOCs. Then first is silicon. Second is paraffin oil. This is high molecular weight oil. This is also non-toxic and stable. Third is D-limonene and alpha pinene. This is found in perfumes and cleaners. This is oil soluble, but not reactive and harmful under culture condition. These are also D-limonene and alpha pinene is also not harmful. This VOCs are found in perfumes and etc. Biological harmful VOCs are like ethanol is there, which is converted into acetaldehyde, and isopropyl alcohol is there, which is converted into formaldehyde. Okay, these are biologically harmful VOCs. Non-toxic VOCs should also be, even if the VOCs are non-toxic, then also it should be minimal. Okay. For harmful effect, VOCs need to have high vapor pressure. For harmful effect, what VOCs need is high vapor pressure. Okay, high vapor pressure. It should be soluble. It should be soluble in culture media or mineral oil and be reactive. Soluble. Third is reactive in culture media and mineral oil, and should be reactive. Should react to the culture media or okay. Factor that modulate contaminants exposure. First is pollution control. Pollution control technology, ability to reduce contaminants. What are that? Contaminants exposure को modulate क्या करते हैं? आपका pollution control technology. First is filter and air system. This will reduce the contaminants. Second is contamination route. Contamination route like air, culture media, gas supply, or lab equipment. This will all modulate the contamination, means it will all change, it will all contaminate, change the contamination. Then absorption or release. Material in the environment can absorb or release the contaminants affecting exposure. Then fourth is chemical reaction. Now chemical contaminants can react to the oils media, can make it less or more harmful, and will alter their properties. Okay, reaction. We can reaction. Fifth is penetration. Penetration. Contaminants can reach the culture system and embryo. Okay, then it may be harmful. Reaction is it will change the property. It will alter the property, but penetration, it will only go, then reach the system. It will reach the system. Then six is biological impact. After chemical reaction and penetration, what biological effect will be there on the embryo and the gamete or blastocyst? That is biological impact. Okay, penetration, biological impact. Then seventh is detoxification. Detoxification, like biological system, gamete, zygote, embryo, detoxify, excretes sometime less or more harmful using enzymes such as cytochrome 450. Like gamete, zygote, embryo, and blastocysts have a capacity to metabolize contaminants. They can detoxify through cytochrome 450. They can detoxify and excrete, can make the contaminants more harmful or less harmful through enzyme. Example, cytochrome 450. Then solubility and reactivity. Now solubility and reactivity. Changes in the solubility in air, water, oil can shift how contaminants move through the system, like how. Okay, 9 is advanced filtration. Advanced filtration like HVAC and gas filters lower contaminants level. This is how the contaminants modulate contaminants exposure. These are the factors that modulate contaminants exposure. Now this is the order threshold. Like order threshold for ethanol is 18 to 100 ppm. This is more common VOCs in art laboratory. Ethanol is most common, and isopropyl alcohol is second most common VOCs in art laboratory. These are order threshold, means uh, like we'll smell it. At what threshold we'll smell. Okay. for the order threshold. Now measuring VOCs and aldehyde in art lab. There are three methods. Okay, first is olfactory, that means smell. Second is photo ionization detector. Photo ionization detector measure VOCs in part per million to part per billion. Part per million means how many zero? Million contain how many zero? 6 zeros. Okay. And part per billion contain how many zeros? 9 zeros. So part per billion equals to microgram per liter. Okay, part per billion. What is part per billion means? Out of 1 billion particle, if there are 1 billion particle in the air, then these are 1 billion particle. One particle is one particle is contaminant. One particle is contaminant. Contaminant. Okay. Now gas chromatography. Third is gas chromatography. This is more sensitive. Gas chromatography is more sensitive and it can quantify around 65 to 75 VOCs with the method EPA TO15 method, and it quantifies VOCs at very low level, that means part per billion. Okay. We have a 6-liter canister air which is attached with the vacuum gauge, and there is a pre-calibrated flow controller. With this, we'll collect the air and we'll send it for gas chromatography to check for VOCs. Now, source of aldehyde in art laboratory setting. What is the impact on the embryo development? If there is an elevated level of formaldehyde, acetaldehyde, and high molecular weight aldehyde, it is linked to poor, delayed, or no embryo development, and reduction of aldehyde improve blastocyst development. Now, common aldehyde in art laboratory are formaldehyde, acetaldehyde, propanaldehyde, butyraldehyde, benzaldehyde, and hexaldehyde acrolein. These are known carcinogens and mutagens. And another common compound is acetonitrile. Acetonitrile sometimes secretes cyanides. Okay. Release of cyanide. What does this cyanide do? This cyanide, it blocks the enzyme in the mitochondria. Okay. This is mitochondria. Cyanide block cyanide. CYANIDE, cyanide. Okay. Cyanide blocks the enzyme in mitochondria, and so it inhibit the cellular respiration. It is secreted by acetonitrile, which is also a VOCs. So preventing the cell from using oxygen efficiently. If it inhibits the cellular or respiration, oxygen won't be efficiently used by the cell. Okay. Then sources of formaldehyde in art lab. There are two sources. One is external source, another is internal source. External source is through photochemical smog and incomplete combustion. Of what is photochemical smog and what is incomplete combustion, I'll tell you later on. Internal source is medium density fiberboard cabinets. Medium density fiberboard, we make cabinets. This secretes VOCs. Okay. And there are compressed CO2 cylinders which also secrete VOCs. And there is, whenever we'll do cold sterilization, there will be use of glutaraldehyde, which also secrete VOCs. Third is pathology biopsy fixation. Their formalin will use, that will also secrete VOCs. And plastic wares, if new plastic wares is there, that will secrete styrene. Okay. Which also is the source of formaldehyde, VOCs. Now, external sources. Photochemical smog. What is photochemical smog? When sunlight reacts with pollutants, it will secrete VOCs, and it will also secrete ozone VOCs. Ozone, if it is in Ozone, if it is present in stratosphere, then it will protect us from UV radiation. But if it is in if ozone is present in ground level, then it will act as a pollutant, and it can cause respiratory issue. It can harm the plant life, and it can also damage the rubber and etc. Okay, it will also smoke can also cause HNO3, nitric oxide, which is the cause of acid rain. Okay, so smog with pollutants and sunlight, photochemical smog is with pollutant and sunlight, VOCs will be released, ozone will be there, nitric oxide will be there. Incomplete combustion can take, like from vehicle hydrocarbon will be emitted. If they are not completely combusted, that will cause VOCs. Okay, that is the source of VOCs. Now has been done. See, this is explained through diagram. External sources like incomplete combustion and photochemical smog, and internal sources like new plastic ware, compressed CO2 cylinder, old sterilization which uses glutaraldehyde, MDF cabinetries. This causes off-gassing of VOCs, and pathology, biologists fixation uses 10% formalin, which also secrete VOCs. This is MDF cabinet, which is MDF cabinet, which is in this off-gassing VOCs. This is Cydex solution for cold sterilization. These are plastic wares which has styrene and which can secrete styrene and is a source of VOCs. We have explained photochemical smog by the diagram. Solar radiation, when met with nitrogen dioxide, which is a pollutant, and water, it can cause HNO3, that is acid rain, and it also met with oxygen and hydrocarbons and etc., and can is the cause of VOCs. Aldehyde, PAN. So O3 plus and O2 plus unburned hydrocarbon can also cause formaldehyde, acrolein plus PAN to be secreted. PAN is the peroxyacetyl nitrate. Okay, peroxyacetyl nitrate. It will secrete this. Now, it is showing hydrocarbon evaporation. Okay, how hydrocarbon can also be caused by coal burning, oil burning, natural gas burning, kerosene burning, propane burning. And this can cause incomplete combustion. We're avoiding VOCs in culture. How can we avoid VOCs in culture? We should avoid VOCs in laboratory. We should avoid introduction of VOCs in laboratory. Whatever VOCs is present in lab, we should decrease that VOCs, and we should decrease the VOCs in the incubator. First is how to do it. First, optimize culture environment. How to optimize culture environment? We have to minimize the time of gamete and embryo spent outside the incubator. Okay, and we have to limit the number of opening of the incubator. That way we can optimize the culture environment and save our gametes from VOCs. Second is risk from external sources. Like external sources risk can introduce bacteria, mold, and toxin, which can affect the gamete biology and embryo development. Third is prevention of contamination. How to prevent contamination? We have to filter the culture medium and air. We'll have to use antibiotic. Triple antibiotic is used in culture media. We'll have to use antibiotic in culture media, and ultraviolet light photo-oxidation for air purification. UVC light is used for photo-oxidation. There is one catalyst, then UV light plus catalyst plus VOCs or microbes, it changes VOCs and microbes into non-toxic substances, like unharmful kind of a substance like carbon, like that. Ultraviolet light photo-oxidation for air purification. UV light illuminates superactivate reactor grid. Indoor air pollutants, bacteria and viruses are drawn to photocatalytic reactor grid. Okay, first is these indoor bacteria, VOCs are drawn to this photocatalytic reactor grid. Then ultraviolet light illuminates and superactivate the reactor grid. Then photocatalytic oxidation reduces the contaminants to simple water vapor and carbon dioxide. Okay, it changes into water vapor and carbon dioxide into non-harmful substances, not which are not harmful. Then VOC exposure and impact on embryo development. Even in early stage of culture, VOC's exposure can affect the embryo development, and it has a long-term effect. Culture conditions influences appearance of embryo. Culture condition can influence the appearance of embryo and during culture, and their performance after culture. Even after culture, if culture is good, even after culture it can appearance of embryo can be affected. Okay. Avoiding introduction of VOCs into laboratory. See, these are the point in which we'll study this avoiding the introduction of VOCs in. First is painting of laboratory, selection of laboratory furniture. Painting will have, now we'll discuss incubator commissioning, off-gassing plasticware, HVAC air intake, smoking, cleaning the laboratory, and miscellaneous sources. First, painting the laboratory. We'll have to use paint with low VOCs or VOCs free paint we have to use. Then we don't have to introduce pigments. Avoid adding pigments at the point of the sale to prevent increasing VOCs content. Okay. Then we have to inform the building personnel that VOCs can impact our embryo. We'll have to inform them before that VOCs can impact the embryo. Then inform building, no embryo culture. Okay. Paint while there is no embryo culture. We have to paint only when there is no embryo culture. Then renovation. During renovation, speed up VOCs release by increasing the room temperature and turning on the lights for days or weeks, so that off gassing will take place, and that time we don't have to keep any embryo culture in the laboratory. Selection of laboratory furniture. As we have discussed already, that MDF furniture we cannot use. MDF cabinet releases formaldehyde. We can use older furniture because older furniture secretes less VOCs. And we have to use stainless steel. Okay, we'll have to use stainless steel, which decreases stainless steel will decreases less VOCs, and we have to clean that stainless steel with isopropyl alcohol before introducing to the laboratory. That stainless steel should be cleaned by isopropyl alcohol before introducing to the laboratory. And we have to use for lubricant, we have to use silicone based lubricant in hinges and in drawer slides. Okay. Then incubator commissioning. The plastic gasket in incubator are the embryotoxic substances. So we'll have to first off-gassed it. We'll have to on incubator for months, okay, before using it in the laboratory. New incubator should be off-gassed whenever possible. Example, what is off-gassing is by running new units will remove the harmful gases from it in a ventilator space, not the indoor lab, at a high temperature for some time, like 1 to 2 months. We have to switch on the incubator, and the temperature should be high, and we'll have to leave it like that, so that there will be off gassing. There will be any toxic VOCs will evaporate. After major repair, ensure part do not introduce new VOCs. After repairing, do ensure that whatever part they are using, they do not introduce any new VOCs in the laboratory. Off-gassing is the process of releasing harmful gases before use. Off-gassing plasticware. Now, what is off-gassing plasticware? See, we use plasticwares in the lab all the time. We use those plasticwares are in the plastic sleeves. The polystyrene plasticware releases styrene. Okay. Off gas plasticware outside the laboratory by opening sleeves in the separate room. Whatever, like if there is test tubes, okay, it will come in the some sleeves. So we'll have to open the sleeve and remove, maintain the sterile condition and remove the sleeves outside the maintain the sterile condition. We'll have to remove the sleeve outside the lab. but maintaining the sterile condition. We can, if there is some laminar hood flow outside the lab, we can keep, after removing the sleeve, we can keep those test tube or central well or any plastic ware in that laminar hood, so that off gassing will take place. Maintain sterility during individual packaged plastic ware like multi well. Now some, if there is one sleeve and there are many plastic ware in that, okay, we can easily use that, because we'll open the sleeves and all the plastic ware will keep in under the laminar hood or in a sterile condition. But if there is separate for everything, we'll have to open every separate plastic ware, we have to maintain the sterility, so it is slight difficult. Individual packaged plastic ware like multi-well dishes and pipettes make it harder for VOC to be released. For individual a solution is to open all the dishes needed for a week. For individual packaging, what we'll do is, the dishes which are to be used for a week, we'll open it, all that are to be used in a week, we'll open it under the laminar hood flow, not in the lab, outside the lab, allowing VOCs to escape. If the plastic ware is with filtered sleeve, means there are gap in the plastic sleeves are with filtered sleeves are there, gaps in the, then has fewer views, because sleeves let gases escape before you open the package. Even before we open the package, that filtered sleeve let gases to escape. Okay, this is sleeves, these are plastic wares. We'll open the sleeve and we'll keep it under laminar hood outside the lab, if or we'll keep in some sterile place so that off gassing can take place. It's better if we keep it in a laminar hood outside the lab. Managing HVAC air intake. HVAC system should reduce, HVAC is heat ventilation air conditioning system. This should reduce VOCs. Outside air may contain high VOCs due to, air may contain high VOCs. How? If there is a roofing repair, if there is a roofing repair, tar replacement, because in roofing, if when we repair a roof, we use tar, okay, tar replacement will be there, so there will be a lot of VOCs. So that way, if high VOCs can be there. Exposure to smoke from the large fire, if there is some fire outside, then HVAC, even HVAC system cannot handle so much of impure air. Parking lot repaving of painting, if there is some repairing during in the parking lot, or there is some painting in the parking lot from where air is coming to the IVF lab through HVAC system, even then there is a lot of impure air which won't be able, which HVAC air system won't be able to purify. Okay, then nearby construction is there, some hole digging is there, all these things, the outside air will get impure. Okay, so whatever HVAC air, it will, whatever air HVAC will take is a very impure air, so it won't be able to remove all the VOCs from that air. So there will be a high VOCs. So what is the solution? Solution is to switch 100% air circulation during high VOC event and monitoring temperature and humidity. So we'll 100%, we won't use outside air. We'll use 100% recirculating air. But the disadvantage is humidity and temperature won't be able to maintain if we'll use 100% recirculating air. Okay, potential consequences of 100% air recirculation is temperature fluctuation, changes in humidity level, and even the positive pressure in the IVF suit will be lost. Now, smoking and lab safety. Smoking near the lab or HVAC air intake can introduce embryo toxin. Okay, we don't have to smoke near the lab. And then third air smoke. Third air smoke is what? Third air smoke is toxic residue that stick to surface and dust after smoke. Even if we are smoking, it can, the toxic substance can be adhered to our clothes or in the walls, and it can stick to surfaces and dust after the smoke clears. Even when the smoke has been cleared, it that toxic residues can stuck to surfaces like clothes, like our body, and that can be introduced to the lab. What is first hand smoke? Whatever the smoker is inhaling. Second hand smoke is what others are inhaling from the smoker. Third hand smoke is even after the smoke is gone, it has stick to surfaces, and dust after the smoke even is gone, it has stick to surfaces. Now, cleaning practices. We cannot clean from ethanol. We cannot use ethanol in the laboratory, though ethanol is a can is relatively micro free. It provides a clean surface and microbe free surface, but we cannot use ethanol because it can secrete VOCs, and it that can be toxic to the embryo. What we'll use is we'll use either sodium hypochlorite, which comes with the name of Clorox, or we'll use hydrogen peroxide. Even some lab prefer only water to clean. Okay. Toxicity from other sources. What are the other sources? Detergent from the laboratory scrubs, solvent in the labeling pen, whatever will label the that cryo lock and everything. So, and dishes also will label. So from that pan, the solvents in that labeling pen can also causes is a potential toxin, can cause release of potential toxin. Then personal care product like shoe polish, hairspray, deodorant, all this can be a toxin. We have to weigh the benefit of using these product against the risk. Decrease ambient VOCs in the laboratory. How to decrease ambient VOCs in the laboratory? Either we can use, two systems are there. One is HVAC system, another is in room air purifier. Okay. See, the carbon, how do we, HEPA filter is for particulate. It is not for VOCs. For VOCs, we in HVAC system, we use carbon filtration or ultraviolet photocatalytic oxidation. Okay. HEPA filter is to remove particulates. Now, HVAC system for VOCs reduction. What HVAC system does is it regulates the temperature, humidity, and it provides a clean air. Key component of HVAC system is HEPA filter. HEPA filter remove molds and spores, and VOCs removal is by activated carbon. Activated carbon is used with the potassium permanganate, because potassium permanganate is oxidizing agent. It oxidizes the VOCs into not non-toxic substances. Now, ultraviolet photocatalytic oxidation. I have already told you this. Ultraviolet rays with catalyst mixed with VOCs and microbes changes these into non-toxic substances like water and carbon dioxide. Okay. Now, filter size and type. We have to choose filter size and type according to the volume of the room. Whichever room we are using, according to its volume, we have to choose filter size and type. Humidity control is also very crucial, because if it is too humid, then mold growth will be there. And if it is too low humid, then drying of the culture will be there. Maintenance, we'll have to maintain the HVAC system by regular filter changes to ensure proper air turnover, and we'll have to monitor humidity also. Here it is told that HVAC system uses both carbon filter and potassium permanganate because it provide an additional protection. Okay, so additional then in room purifier, these are not as potent as HVAC system, but it can be used. These are portable devices which reduces VOCs but are less effective than HVAC system. It require regular filter changes for effectiveness. We'll have to change in a room purifier, we have to change filter regularly. Then decrease VOCs in incubator, purchased gas. Now we are talking about, right now we talked about decrease VOCs, how to decrease VOCs, and okay, outside the incubator. We were talking about like we have to decrease VOCs introduction, and we have to decrease the ambient VOCs. Now we'll talk about decrease VOCs in incubator. We'll have to buy that incubator work gases to work. Okay. Incubator has gases. So that gases, we have to buy highly purified gases. So we have to tell the that from whomever we are buying the gas, we have to tell them that we are buying it for our lab, and lab require highly purified gases. So the gas cylinder we'll buy should be with high purity medical gases. Okay. We'll have to tell the supplier that we need it for our IVF lab and it should be highly purified. Then inline filter. Inline filter is through that gas. There should be one inline filter means, see, gas cylinder will be attached to this line. So there should be one filter here in the line. This is called inline filter. Then through that filter, the gas should go to the incubator. So this filter should use carbon and potassium permanganate. Potassium permanganate, as I already have told you, that is it's a strong oxidizing agent filter. Activated carbon. Okay. What does carbon do? What carbon does is carbon absorb VOCs into the porous surface and typically trap them physically. But what potassium permanganate do? It is a redox agent. So it oxidizes VOCs into the non-toxic byproduct like CO2 and H2O. And what we have to remember is we have to replace filter regularly to maintain air quality. See, this is inline filtration. Can you see inline filtration? This is the line from the gas, from where gas is coming. This is inline filter. See, this is the line from where the gas is coming. This is inline filter, and this must be incubator. Okay. Here I have told about that redox agent, that is KMNO4. It oxidizes the VOCs into the less harmful form. Incubator type. Now, if it's a big incubator, traditional CO2 big incubator, then it will use air. Okay, outside air. It will use outside air. So VOCs from that air will enter the incubator. But benchtop incubator and modern incubator, benchtop incubator, there will be flushing of the air from the flushes the chamber. As the incubator flushes the chamber with the mixed gas will be flushed into the incubator. So if there is some air from the outside, that will be flushed out. So there will be less VOCs, because in the big box incubator, the VOCs are coming from the air. So if in the benchtop incubator, the gas will be flushed in the incubator, so the air will be flushed outside the incubator. Ambient room air will be flushed outside the incubator. Okay. So there will be less VOC. Intra-incubator recirculating filters. Now inside the incubator also we have some filters. Okay. In big box incubator, gas is recirculated. Big box incubator, gas, there is some carbon filters. Gas is recirculated inside the incubator. Gas is recirculated through this carbon filter. And time lapse and benchtop incubator. These incubator continuously mix gases and recirculate them through an additional carbon filter. There is some carbon filter. Okay. So there will be some inline filter. There inside there will be some carbon filter. So this is double the filtration compared to the system that only filters gases in the gas line. It will filter from here also. Right now I'll show you the diagram. Important condition: effective only when the atmosphere. Okay, these carbon filters are not effective during high humidity. It is only effective when atmosphere is not humidified, and water on the surface of carbon filter reduces their ability to remove VOCs. See, this is in intra incubator filter for big box incubator. It is kept in, see, this filter is kept inside the incubator, big box incubator. Now benchtop filter, see, this is kept in benchtop filter. It is also can be seen in the time lapse and benchtop, both. This one is so there is actually double filtration: inline filter and intra incubator filter. Decrease VOCs in culture. Now, VOCs can infiltrate from gases inside incubator or brief exposure to room air. Okay, see, in the inside the incubator there will be VOCs, and if we'll open the incubator, VOCs from the ambient air can enter the incubator. So from that, VOCs can enter the culture. Either if will how will it enter from the air? Either we'll open the door, or when culture is taken after work, we'll keep culture inside the incubator. So both of them can introduce VOCs in the culture. So if VOCs is inside the culture, it is difficult to remove. Difficult to remove. There are actually two VOCs. One is hydrophobic VOCs, another is hydrophilic VOCs. Hydrophilic. Okay, hydrophobic and hydrophilic. Hydrophobic are like benzene and styrene. Hydrophilic are like ethanol, formaldehyde, acrolein, glutaraldehyde. Okay, these hydrophobic VOCs can, because it loves water, no? Hydrophobic. So this can enter the embryo membrane and harm the embryo. And this hydrophilic can enter the cytoplasm and likewise harm the embryo. I've already discussed type of VOCs: hydrophobic VOCs, hydrophilic VOCs. Hydrophobic are like benzene and styrene, and hydrophilic are like ethanol, acrolein, formaldehyde, and glutaraldehyde. What are the uses of oil overlay? See, why is oil overlay used? It prevents the loss of CO2. This is culture. Okay. This is oil overlay. CO2 loss will be decreased, but it has negligible effect in CO2. Why? Because there won't be any regassing. Regassing won't be there. So, like if this is CO2 incubator, there there is culture. This is oil overlay. Now CO2 cannot even enter the culture. So there won't be any regassing of CO2. So pH won't be maintained. Are you understanding? Like this is whatever. That's why we incubate it. The culture is incubated pre-night. Okay, before only we incubate the culture so that CO2 is present in the culture and pH will be regulated. Because now after overlay, it won't allow CO2 to go inside also. Even that is useful. If CO2 goes inside, that is useful. So, but it won't allow it to go inside also. Okay. So prevent loss of CO2. Even loss also it will prevent, and it won't let CO2 go inside also. Then stop desiccation of culture media. When we put, this is culture, okay? This is oil overlay. So it will stop drying of the culture media. Second is maintain the stable temperature, especially when culture are taken out of the incubator. Then detoxify culture medium. This oil overlay will detoxify the culture medium. How? It will reduce hydrophobic VOCs level. Why it will reduce hydrophobic VOCs level? Because whatever is present in the air and whatever even in the culture, it will go to the hydrophobic will go to the oil overlay. Okay, oil overlay. Instead of the culture media, it will go to the oil overlay. And another thing is how it will detoxify VOCs partition into the oil at higher condition. It will act as a partition into the oil at higher concentration and dilute VOC in the oil phase, lowering the concentration in the aqueous phase. See, it will dilute. First of all, if it will be higher concentration, VOCs will be higher concentration, it will go into the oil. And another thing is, that's why we use blank oil. Sometimes we use blank oil, not any culture, just oil. We use in the incubator so that any high VOCs is there, it will enter the oil and it will stay there so that it will reduce the VOCs in the incubator. Okay. Dilute VOCs in the oil phase, lowering their concentration in the aqueous phase. So it will go inside the oil overlay. So in the culture, this is culture, it won't be there for the culture media. It will dilute for culture and it will be present in the oil overlay. It acts as a partial barrier. It is acting as a barrier, but it is not a absolute barrier. Okay, VOC can still enter. VOCs can still enter even if it act as a barrier. VOCs can still enter if prolonged exposure of VOCs will be there. Now we managing. Oh, same thing. It is repeating again. Hydrophobic VOCs. Yeah. Hydrophobic VOCs. Uh, see, this is aqueous culture. This is oil overlay. So oil overlay. Okay. This is all oil overlay. So what will happen? VOCs will move to oil. First thing. Second is dilution. Why there will be dilution? Because oil volume is more than aqueous culture volume of oil more. So there will be, sorry, more. So there will be dilution. Hydrophilic, what about hydrophilic? It will cause dilution effect because oil volume is much greater than the medium. Now hydrophilic VOCs. This is culture, huh? This culture medium. This one is oil overlay. Hmm? So what will happen? Oil slows down. Hydrophilic VOC, it will slow down. Now it will take time to reach the culture medium. Even if it's hydrophilic, it acts as a barrier and VOCs will take time to reach the culture medium. If it will be if for long time VOCs will be exposed, then it can harm. Otherwise, for shorter time, it won't affect the it won't affect the embryo because it will take time to reach the culture because oil overlay is acting like a barrier. Okay. So short exposure, no embryo damage. Short exposure, no embryo damage. Huh? Long exposure, it can eventually reach the culture medium. Then we talk about large surface area, small surface area, and dilution. Huh. See, if there will be large surface area, then more VOCs will be absorb more harmful chemical from air. Second, small surface area and deep. Small surface area and deep. Minimize absorption of VOCs. If the oil layer is deeper and covers smaller area, it absorbs fewer harmful chemicals because less oil is exposed to the air. Okay, if it is deep and small surface area, see, deep and small surface area, less VOCs will be absorbed. Third is dilution effect. Large volume, if it will be in large volume, okay, large volume, then dilution effect will be more. So oil overlay in practice, we use oil sinks, blank dishes filled with oil, so that it will act as oil sink and absorb VOCs from the air. Impact on CO2 and pH. Oil overlay shows slow down the exchange of carbon dioxide. So that's why pre-incubation is often needed to ensure the culture medium reaches the correct pH before being used for culture media. Pre-incubation, we do overnight incubation so that CO2 is reached to the culture medium and pH is already maintained, because if we'll do oil overlay, then regassing won't be allowed. Okay. So previously we studied about the surface area, volume, and oil exposure. So for uh, uh, culture, we should have deep container. We should have deep, something deep. Why? So that surface area is less. So there will be less VOCs, which reaches the culture drop. Okay. Oil over should be deep. Oil over should be deep. Surface area should be deep, means volume is more. Surface area should be less. Less surface area means less dissolution of VOCs. Okay. So there will be less VOCs which will be reaching the culture drop. Oil, this is oil overlay. There will be less VOCs which will be reaching the culture drop. Now consensus points. Okay. Clean room design for art lab. Art lab should have air quality comparable to ISO class 6 and GMP grade BC. But see, in this ISO class 6 and GMP grade B6, there are many air changes. So in IVF lab, we do not want that much of air changes. These classification have made for surgical suits, but we are talking about art suits. We don't need that much of air changes because that will cause cooling of embryo. We need less air changes. So though for the particle size, we can say that we'll use ISO class 6 and GMP grade B and C. So what does ISO class 6 says? ISO class 6 says greater than 0.5 micrometer particle should be less than 35,200. Okay. Okay. So this, see, greater than 0.5 micrometer particle should be less than 35,200. Okay. This unit is in particle per cubic meter. What does that mean? If this is a cubic meter, okay, this is a cube, this is a cube, this is also 1 meter, this is also 1 meter, and this is also 1 meter. So in 1 cubic meter, the particulate should be less than 35,200. Okay, this is ISO class 6. Now in ISO class 6, there are 150 to 240 air changes per hour with ceiling coverage of 25 to 40%. But this is not suitable for IVF lab. Okay, this can be used in surgical suits, but not in the IVF lab. Clean room classification according to EU GMP. Okay, at rest, we prefer C, and at in operation, we prefer B. At rest, we prefer C. That means 0.5 micrometer particles are less than equals to 3 lakh 52,000. Okay, 3 lakh 52,000. Same in operation, we prefer B. 3,52,000. 0.5 micrometer particle is 3,52,000. 0.5 micrometer particle is 3,52,000. Means at rest we prefer C, and in the operation we prefer B. Okay, we have done this. Now, see middle ground, ISO 7 class. Okay, we come in a middle ground. This was very specific. ISO 6 is very, like, it is difficult to maintain. So we came in a middle ground where ISO 7 is followed, where 3,52,000 particles greater than less than 3,52,000 particle, which is in the size greater than equals to 0.5 micrometer. Same, at rest also, same in operation also, 3,52,000 and 3,52,000. This we come in the middle ground, means because that was very difficult to maintain ISO class 6. So we come in a middle ground, which state this. Okay? This can be achieved with now, but air changes, we want less air changes. That is 10 to 15 air changes per hour. 10 to 15 air changes per hour. Per hour. Now, procedure room. Procedure room, like where oocyte retrieval is done, where embryo transfer is done. Okay. And procedure room is like embryo, and where percutaneous sperm retrieval is done. Okay. This is called procedure room. If in this room, invasive surgical procedure, because in procedure room we do all this. In IVF suit is like, this is IVF suit, this will be procedure room. So there is a single HVAC system in the both room. Okay, but if we do some invasive surgical procedure also, these does not come in the invasive surgical procedure. Okay, these does not come. But if we'll do some invasive surgeries also there in the procedure room, invasive surgery, we need to have a different HVAC system. If we are doing some invasive surgery, different with a separate HVAC system from the R2 with surgery is involved. Okay. फिर mobile air filtration. Mobile air filtration, we can use achieve a air quality standard at rest, but does not provide positive pressure. It does not provide a positive pressure. Now we'll talk about the points in the Cairo Consensus. Okay, all the points in the Cairo Consensus we'll talk about. First is site suitability. It should be away from the heavy pollution. Heavy pollution, say it should be away. Area should be where we'll build our IVF lab. The area should be away from the heavy pollution, and test for VOCs in and around the building should be there, so that we cannot make the IVF lab where VOCs are very high. And review local air data on particulate matter. How much data is there on particulate matter, like how much PM5 and PM10, how much particulate 5 micrometer particulates are there, how much PM10 is, how much 10 micrometer particulates are there. We'll have to see that data for that area. Okay. VOCs analysis. Test for VOCs in and around building. VOCs can evaporate into the air and harm embryo, so maintain a safe level is crucial. Low air quality. We'll review local data on particulate matter PM5 and PM10. PM5 is 5 micrometer particulates and PM10 is 10 micrometer particulates. Nearby pollutions also we'll have to see. Then first point is site accessibility. Okay, site suitability. Now second point will come, basic design criteria, new construction. How should be the design of the IVF lab? First is air quality. Okay, air quality. The art lab should have HEPA filter air quality equal to that of an operating room. Art lab should contain, second point is, art lab should contain air quality should be good. Like if HEPA filter should be used. Okay. Now air quality, we'll talk about the particulates. Particulates should be less than 3,52,000 particles, larger than 0.5 micrometer point microgram, equal to less than 10,000 such particle per cubic feet. Now, see, 1 meter cube is equals to 35.3 cubic feet. Okay. Means if 1 feet is multiplied 35.5 times, then it will come to be 1 meter. Okay. So we can say 10,000 because 10,000 into 35.3, it equals to 3353,000. That means equal to 3,52,000 per meter cube, or less than 10,000 per cubic foot. Are you getting me? This both are equal. Just this much of difference is there. It's coming 3,53,000. It is 3,52,000 per meters cube, and it is coming 3,53,000 per cubic foot. So it is almost equal. So air quality HEPA filtered. The art lab should have HEPA filter air quality equal to that of an operating room. Microorganism will have the art lab less than 10 colony forming units per meter cube. If there is one square, sorry, if there is one square, okay, of 1 meter, then less than 10 colony forming unit should be there, and less than 2 spores. See, spores are very resistant, na? So it should be what is colony forming unit? It is number of viable microorganisms in air that can form colonies. And spores is like bacterial and fungal spores and bacterial spores. These are hard to eliminate. Okay. So there should be less than two spores per meter cube at rest. Now, fifth point is VOCs. Total VOCs must be less than 500 microgram per meter. That is equals to 400 to 800 part per billion, depending on the molecular species, to prevent gamete. We will talk about VOCs. Okay, VOCs. Total VOC should be less than 500 microgram per meter cube. It is according to weight. Now, according to particles, we say it is less than 400 to 800. Why so much of part per billion? Why 400 to 800? Because if particle is larger, then lesser number of particle will weigh same weight. Matlab means 500 microgram per meter cube, but less number of particle. And if particle is small, more number of particle will weigh same weight. More number will weigh same weight. That's why so much difference. 400 to 800 parts per billion is said. What is parts per billion? See, if there is some space, okay, parts per billion. There are billions particle of air in that space. And there are there are 5 VOCs in that billion particle. Okay. So we'll say 1, 2, 3, 4, 5. What we'll say is, we'll say 5 part per billion. Means if there are billion particles, then only 5 particles are VOCs. Okay. we have talked about the VOCs. To prevent, aldehyde must be less than 5 microgram per meter cube, as they are highly toxic. It should be less than 5 microgram per meter cube. Okay, because aldehydes are highly toxic. Now see, it is shown that this is particles. Okay, this is particles. These are microorganisms, and this is VOC. So all this is filtered. Okay, what particles? We have talked about particles. We have talked about HEPA filter, microorganisms, and VOCs. This is to remember. Basically, this is a mnemonic to remember, visual mnemonic to remember. HEPA filter we have talked about, VOCs we have talked about, particles we have talked about, and microorganisms we have talked about. All 4 points we have talked about. Okay. Now we'll talk about air changes. Air changes should be 15 total air changes per hour, including three fresh air changes per hour. Means 20% outside. Fresh air changes mean 20% outside air. Considers VOC filtration type, manufacturer instruction regarding air changes. Overpressure. Optimal pressure should be, we should maintain a positive pressure in the laboratory. Optimal should be plus 38 to plus 50 Pascal in IVF lab. Minimum recommendation is plus 30 Pascal across the room to manage pressure. Temperature should be maintained in 20 to 24 degree Celsius. Okay. Humidity should be maintained between 40 to 45% to avoid mold growth, to ensure comfort, to avoid high evaporation rate that could affect the osmolarity of the high evaporation rate, so that osmolarity of the culture medium is not affected and does not harm the embryo. See, this is a picture mnemonic. See, I have made one pressure cooker kind of thing, and this is the burner. That means temperature. This shows the temperature. This shows the temperature. Okay, temperature. This shows the pressure. This is pressure. Okay, pressure. This shows air changes. Fan is for air changes. This is picture mnemonic, so that we remember all the 50 points of the consensus. And this water is showing humidity. Okay. Now sealing. Ensure the lab is sealed with specific material. Daily inspection are recommended. Whole lab should be sealed because we have to maintain a positive pressure. We don't want any dust to come in, as we have to maintain a positive pressure. So the whole lab should be sealed. Okay. Now activated carbon and potash, and we have to regularly check if it's sealed or not. Activated carbon and potassium permanganate filter. So for VOCs, we use chemical filter for removal of VOCs. Why is HEPA filter there? Removal of VOCs. HEPA filter is to remove particles. Okay. For VOCs, we use chemical filter. In chemical filter, what we use? Activated charcoal and KMNO4. What is KMNO4? Potassium permanganate. Potassium permanganate is oxidizing agent. And this activated charcoal, by absorbing the VOCs, it removes. This oxidizes. This is oxidizing agent. So it oxidizes the VOC, and this absorbs the VOCs. Activated charcoal absorbs the VOC. KMNO4, potassium permanganate, oxidize the VOCs. And the residual residence time is 0.2 to 0.35. What is residence time? Residence time is for how long air stayed in contact with the filter material. For how long air stayed in contact. Like this is the activated charcoal and KMNO4 filter. Okay. So for how long air has stayed in this is activated charcoal and camera 4 filter. So we'll see for how long air has stayed in this filter. Okay. It should be less than 0.2 to 0.35. Resident time should be less than. Heating and cooling of incoming fresh air. Make sure the system heats or cool fresh air as needed based on the local climate. Isolating external air. HVAC system should be able to fully block the outside air during emergencies. See, if this is IVF suit, art suit, if there is some emergency, like there is fire outside the art lab, okay? There is fire outside the art lab. This is fire, okay? So we don't want this smoke to go into IVF lab. But we read that in IVF, we read that 20% is 20% of the air is coming from outside. 3 fresh air should be there, no? 3 fresh air. So 20% was coming through outside air. But during emergency, the art lab should block the outside air. Like when emergency, like when there is fire outside. So we don't want any smoke to go to the art lab. So it will block. No air from the outside will come into the art lab. Okay, that's it's telling. Fire, high pollution, nearby construction in this submarine mode. But what is the disadvantage of all recirculated air, no fresh air? What is disadvantage is it cannot maintain the overpressure, but it will actually protect them from the harmful air. Okay. See another picture mnemonic, heating and cooling of incoming fresh air. However the climate is, it can make the air suitable for the embryos. Okay, it can for our culture and embryos. Isolation, see this seal is isolated, this seal is isolated. So isolation, that isolation external layer means when there is some emergency, we can isolate the art lab so that the outer environment does not affect the isolate the art lab means no outside air should enter the art lab. Okay, sealing. We have to maintain the sealing for positive air pressure. And then activated. See this picture mnemonic contain this charcoal. Okay, activated carbon and potassium permanganate filter. Now 14th point is air supply vents. What should be there? Air supply vents. The incoming air should come from above and outgoing air should go near the outlet should be near the floor. Okay, HEPA filter. HEPA filter should be located centrally. And air quality. To achieve optimal air quality, the system should be recirculated with only 20% fresh air to create a necessary overpressure. We have already discussed that. Then pressure sensors. Pressure sensors and differential pressure display should ideally be installed on each side of door, inside and out of the and between areas within the suit. There should be pressure sensors everywhere so that we can know that art lab is maintaining the positive pressures. Okay. See, this HEPA filter is there, and fresh air inlet is here. Fresh air inlet is coming from the outside. We need 20% of the fresh air inlet. Then this is air handling unit. This is air handling unit. This is this is coming from floor, coming near the floor, है ना? This is near floor. This is outgoing air, and this is incoming air. Okay, this is outgoing air, this is incoming air, this is HEPA filter. So schematic drawing, this air is entering, this should be from ceiling. Entering air should be from ceiling, and the exit air should be near the floor. There are 3 type of filters: HEPA filter, ULPA filters, and VOC filters. Okay. What is different between that? HEPA filter is high efficiency particulate air filter. ULPA filter is ultra low penetration air filter, and VOC filter is VOC. So this is HEPA filter, this is ULPA filter, and this is VOC's filter. This is inline filter. We are seeing inline filter, inline VOC's filter. Okay. HEPA filter efficacy is lesser than ULPA. ULPA is even more efficacious. Okay, ULPA provide ultra clean environment. Airflow resistance is higher. means, and cost is also high, and maintenance more frequent. Okay. Airflow resistance is higher means what? Means it does not allow all the air to pass. Okay. So resistance is higher. It will pass only, it does not allow, it blocks the impure air. So resistance is higher. It needs more it will consume more electricity also. It cost will be higher also, but it is more it has more efficiency than a HEPA filter, but most of the laboratory we use HEPA filter. Sealing the box. Effective overpressure must be achieved by building a clean room suit to minimize air loss, ensuring airflow out of the embryology laboratory. See, we have to maintain the overpressure so that the air flows outside of the laboratory, and so that air dust and other particles also does not enter the lab, IVF lab. Slab to slab wall. Slab to slab wall. uh we'll see slab to slab wall. See, it should be made slab to slab wall means exterior wall of the clean room must go from concrete floor to underside of the floor, slab to slab. There shouldn't be any perforation. All perforation, everything should be completely sealed. Okay. Now sealing. Sealing should be made of what? Sealing should be made of composed of solid contiguous material. What means contiguous material means what? Contiguous material means which does not have pores, cracks like this. Okay. Example. What is the example of these materials? Like plasterboard, gypsum panel, and gyprock and sheetrock. Okay. With minimal access panel. There should be minimal access panel. Access panel is the, what is access panel? Access panel means it is a gateway through which we can go inside to adjust something, or to we can go to like if we'll do some plumbing work or some work, HEPA filter, if we want to exchange or we want to repair, there is some access panel through which we can go and do all this. So that should be minimum. Okay, there shouldn't be much access panel. Now we'll talk about plasterboard. What is why we use plasterboard? Because it is smooth. Okay, it is smooth, lightweight, cost effective, and easy to install. And easy to install. Easy installation. Okay. And this all support sterile setup. But gypsum panel, gyprock. Gypsum panel, what does it does? What it does is it is fire resistant. Fire resistant. It has a low VOC and easily maintained. It is also cost effective. Okay. Gyprock. It is advanced gypsum material. Gyprock is advanced gypsum material. It is moisture resistance. Okay. Moisture resistant and durable. It will resist mold and ideal for control environment. It will resist mold and it is ideal for control environment. Ideal for control environment. Now sheetrock. Sheetrock, high quality, mold mildew resistant. Mold resistance and mildew resistance. It is also like a mildew is also like a mold only. Okay. Resistant, high quality. It is high quality sheetrock. Okay. Resistant. It is reliable for hygienic, sterile conditions. Then light fitting. Light must be airtight. Light fitting must be airtight. So that to prevent air leakage into the plenum void. Surface mounted fittings are acceptable if cable access is sealed. Okay. वैसे it was written that it should be
on the ceiling, not in the ceiling, on the ceiling, and it should be on the ceiling, but surface mounted fitting are acceptable. Surface one is acceptable, but cable access are acceptable if cable access is sealed and there are no horizontal rim or flanges. Okay. Now, electric gas and data conduit. All this electric gas data conduit should be sealed. Do you know dado trunking? Dado trunking. I'll show you the diagram right now. Dado trunking is like a plastic box in which all the wires will pass through. Okay. This is called dado trunking. So dado trunking within the suit for distribution of power, data, and gas line. We'll use it for power, data, and gas line. Gas line. Okay. This is a plastic kind of a box in which there will wires will go inside it. Doors. Doors must be tight fitting with bottom sweeps, perimetric seal, top and edges. Okay, perimetric seal can be achieved with the gaskets. Bottom sweep, I'll show you the diagram. Any view panel must be mounted using gasket to ensure there any view panel. Any view panel. This is view panel. This is glass view panel. This should be gasketed, sealed. Okay. Then pass through must be airtight to maintain room air pressure differentials. See, as we enter the IVF lab, this is door. This is totally sealed, and this is pass through, and this is pressure sensor. Pressure sensors, door, pass through, and this is the hand wash area. I have made diagram also to remember points. Okay. Fourth thing we are seeing here, doors which should be sealed, the and which should have a bottom sweep. Bottom sweep should be there, a pass through which should be sealed, and a pressure sensor should be inside and outside the door, not door, near the door. Okay. And this area should be outside the door, the hand washing area, and clean room doors. See, it's all gasketed. It's all gasketed. So means it's all gasketed means all sealed. This is observation window. Okay. This is pass through. This is sweep. What we call it? Bottom sweeps. This is bottom sweeps. Okay. These are bottom sweep in the doors. This is ceiling. Lightning, surface mounted lightning can be acceptable. These are the walls. This is flooring, vinyl flooring. This is dado trunking. Can you see this plastic box? This is dado trunking. Walls. True clean room modular panel with powder coated material. Powder wall should be with the powder coated material. Gasketed interfaces should be there, and plasterboard coated with the zero VOC paint. Okay. Floor, vinyl floor. I have already shown you this floor. Vinyl flooring should be there. Vinyl floor should be there. Vinyl floor with impervious seal joint. Stainless steel tread plates in the area with liquid nitrogen. See, wherever liquid nitrogen is kept, stainless steel tread plates in the area with liquid nitrogen. Stainless steel tread plates is kept. Okay. See, what is countertops? Countertops are the flat surfaces flat surfaces like in laboratory, kitchen, where we do work. Okay. So it should be made, countertop should be made up of epoxy. Korean Korean movies we watch now. Counter crispa, so that views to prevent VOC's release and to ensure non-porous and easy to clean surfaces. 27th point is sealing. Sealing should be gasketed and sorry, gasketed and sealed. Any access panel panel in the ceiling and to minimize panel, like we can make some excess panel so that we can go and we can do our okay. Now 26 is countertop. Countertops are the flat surfaces, like in kitchen, laboratory, where we do work. It should be made of epoxy, corian, and tripsa to prevent VOC release and to ensure non-porous, easy to clean surfaces. Okay. Then ceiling. Ceiling should be there should be minimum access panel in the ceiling. Access panel is the area where we can from where we can go to for maintenance something or for changing of the filtration, like that. There should be minimum access panel and it should be gasketed and sealed. Okay. Windows should be made up of glass. It should be gasketed, and there should be if there is a small window, it should be mounted indoors. And for the large observation window, it requires proper seal. In window, spectral filter for outside window should be there to exclude UV light. Now cabinet, we'll use cabinet. What are cabinet? These are the for storing goods. Okay. Almira kind of. It should be powder coated metal, made up of powder coated metal or stainless steel for durability. It should be non toxic and it should be contamination resistance. Wood product should not be used. I have already told medium density fiberboard product, wood product should not be used. Linoleum product should not be used. Oil based paint should not be used due to embryo toxicity. See, I've already explained about the stainless steel tread plates, which should be used in the area where liquid nitrogen is being used. Uh, 31 is hand washing facilities. I've already shown the hand washing facilities. It should be located in the vestibule rather than in the laboratories. That vestibule is made, separate vestibule is made. Right? Vestibule is the area. See, there are two doors here, here. Between space is called vestibule. Okay. Waste pipe required traps, like pipes and all should be enclosed. It should not be open. Then noxious and corrosive chemical. These should not be used in the IVF lab. So we do not require a trench shower in the IVF lab. If required by the local code, ensure traps do not dry out. Okay. Now fire suppression system, sprinkler are there, no? So there should be some cover in the sprinkler so that if we use the sprinkler, there should be cover or something so that if accidental triggering does not happen. Okay. Then the open flame, we should not use open flame. If open flame are used, conduct a risk assessment of fire likelihood and exposure to combustion product. We should not use open flame. If at all we are using open flame, there is risk and exposure to the combustion product to the embryo. So basically it should not be used. Plumbing. We do not in the plenum, like in IVF lab, we used closed plenum. Okay, plenum is the area where above the ceiling, the area where like filters are and all those things are kept. That is called plenum. So basically, we should not use plumbing in the plenum. Okay, avoid unnecessary plumbing in the ceiling plenal spaces, and it poses risk of flooding and contamination, especially during renovation. See, corrosive materials should not be used. Then corrosive materials should not, and noxious. This open flame should not be used. This plumbing in the plenum should not be used. Okay. This where all HEPA filters and all above the ceiling, where all these are kept. This is called plenum. And in IVF lab, we use closed plenum. Laboratory commissioning and ongoing VOC management. 26 is burn in. See, newly constructed or renovated laboratory if some laboratory is newly constructed, off guessing should be there for 2 to 3 weeks minimum. Okay, and which should be verified by specific VOC testing. VOC testing we have to do, not bioassays like human sperm survival test. Okay, we'll have to do with specific VOC testing. Then deep clean. You see, laboratory should be cleaned from intensive cleaning of all surfaces, including hard to reach corners, cupboard, drawers, and equipment. Cleaning products should remove all contaminants, but we would not allow any cleaning agent residue also. We'll again clean it with the distilled water or sterile water. Then servicing. A clean room HVAC system must be serviced annually. Okay, HVAC system is serviced annually or more frequently if performance fail to meet the expectation. We'll have to use three filters. What three filters we'll use? Pleated particulate filter, which should be changed every 90 days. Okay, means 3 monthly. HEPA filter, which should be changed 2 to 4 years. And third filter is carbon filter, that is called chemical filter, which there is no set interval for the change of the chemical filter. We'll change it according to the environment. Okay. If there is fire or if there is construction going on in that area, then chemical filter will be changed frequently. So we cannot like we cannot say that this is the optimum time to change the chemical filter. And laboratory previous performance also we can see that when to change. Facilities filter consumption history should guide replacement schedule for chemical filter replacement. Pressure differential across filter should be monitored using gauge like McNeil. What will it do? Pressure differential, if will monitor using gauge like McNeil, what will do is it will tell us if some filter is blocked or if there is something wrong with the filter. It will tell us the pressure difference. Optimal pressure difference will be there. Okay, this much pressure difference should be there, and that optimal pressure difference is not there. It will tell that filter is not working properly. There is some block in the filter or it needs to be changed. Okay. See, this is pleated filter. This is pleated filter. Pleats. Can you see the pleats? Okay. This is HEPA filter. This is activated carbon filter. And this is magni gauge, which tells about the pressure difference, okay, between the input air and output air, so that we can know if filter is working efficiently or not, if there is a block in the filter or not. With this, we can tell. Then see, first air will go through pleated filter, then HEPA filter, and then chemical filter. See again, pleated filter, HEPA filter, and carbon filter. See, the chemical filter will remove the gases and VOCs, and HEPA filter will remove dust, pollen, microscopic particles. Okay. HEPA filter will remove dust, pollen, microscopic particles, while the chemical filter will remove gases and VOCs. HEPA filter purifies, filter out pollen, viruses, dust, and molds. Carbon air purifier filter VOCs, secondhand smoke, wildfire, wood smoke, heavy odors. Basically, these gases and VOCs and smoke. Okay. And odor also. Odor. This आपका pollen, viruses, dust, and molds. 39 is infection control. Infection could measure used infection control measures used in hospital might be embryotoxic. We cannot use hand sanitizer for in art suit, okay, because that can release VOCs. And now aldehyde based cold sterilization. We cannot use aldehyde based cold sterilization because aldehyde based cold sterilization uses glutaraldehyde. Okay, it should be outside the lab. It cannot be used inside the lab. Cleaning agent. Okay, cleaning agent, bleach should not be used. Chlorine dioxide, bleach should not be used. Okay. If we can use 6% H2O2 hydrogen peroxide we can use, or is recommended as it oxidatively destroys microorganisms and easily removed. Alcohol, 70% ethanol, isopropyl alcohol are less effective as they only denaturate protein. Okay, isopropyl alcohol and ethanol and isopropyl alcohol should not be used as it only denaturate protein. H2O2 will kill microorganisms and it is easy to clean. Like we cannot have the residue of cleaning agent also. It has to be clean. So H2O2 is easy to clean. Now, what we use is like USAFE we use basically in the IVF lab. What is it? It is a quaternary ammonium compound based cleaner. Alcohol free alternative such as it is a USAFE. It is a quaternary ammonium compound based cleaner. Ammonium compound based cleaner. Okay, traditional are considered safe and can replace traditional alcohol or bleach based cleaners. Care must be taken to ensure embryo are not exposed to the residue of these cleaning agents. Even these cleaning agent residue should not be there. Embryo should not be exposed to these cleaning agent residues. See, this is USAFE. USAFE. Okay. This is USAFE, quaternary ammonium compound, safe disinfection for CO2 incubators, laminar flow hood, glass, plastic metals, high mech surfaces, equipment, ultrasound probe, and hospital furniture. These come in five, 1, 2, 3, 4 groups. First is 5 liter. This one is 5 liter. Then it is 1 liter. This one is 1 liter. Then 50 ml spray. This is 50 ml spray. Then wipes. It comes with wipes. This is wipe. Okay. Now this is for floor, laboratory surface and floor. Safe disinfectant and cleaning for laboratory surface and floor. It is also compatible with glass, metal, rubber, plastic, wood. So it comes in three bottles. First is 10 liter refill. Second is 2 liter with dose cup. And third is 50 ml. Okay. This is 2 liter with dose cup. This is 10 liter refill. See, the USAFE disinfectant for CO2 incubator, laminar flow, hood, glass, plastic, high mech surfaces, equipment, ultrasound. This is used without dilution. We do not need dilution for this, but the surface disinfectant need dilution with water, 1:100. Okay. And the microbiological efficacy for the this effective against hepatitis B, HIV, rotavirus within 1 minute, and against bacteria, fungi, candida, and influenza A virus within 15 minutes. And about USAFE surface disinfectant, effective as a bactericidal, fungicidal, algicidal, selectively virucidal. Application instruction: apply evenly on the surface using spray or wipe. After application, wait for 15 minutes and clean with humid sterile sponge or cloth to remove residue. Even USAFE residue should not be there. So we'll remove the USAFE residue with sterile water. And in the USAFE surface, these both are quaternary ammonium compound. These both, even for surface and even for incubator laminar root, both are quaternary ammonium compound, which is relatively safe. Okay. It should be diluted. The surface disinfectant should be diluted with water in the 1:100 ratio before application. After application, wait for 15 minutes and rinse the surface if used on floor to prevent slipperiness. Now, plastic ware. See, plastic ware also, first off-gassing should be done. Okay. Even plastic ware off-gassing VOCs, especially polystyrene, which release embryotoxic styrene. All plastic cultureware should be off-gas outside the laboratory. Plastic cultureware should be off-gas outside the laboratory while maintaining sterility. Manufacturers are encouraged to use breathable packaging. Even packaging should be breathable, means some filters or should be there in the packaging so that off-gassing takes place regularly. Otherwise, we'll have to remove the package and we'll have to keep it in a sterile environment outside the lab in some high temperature so that off-gassing can take place. Packaging material. Packaging exposed to outside environment like cardboard must not enter the art suit, and it can introduce fiber, dirt, fungal spore. Packaging, because it will all come in a cardboard. All package will come in a cardboard, है ना? These packages will come in the cardboard. So it can come because it is in the cardboard. It can with this, if we'll keep it inside, with this fiber, dust, fungal spore can come into the IVF lab. Particulates can come in the IVF lab. Minimize the use of interior cardboard and paper packaging in art suit. So we don't have to use paper packaging and cardboard in the art room. We'll have to do off gassing outside the art room in a sterile environment. Then cleaning and cosmetic product. We cannot use nail polish, lipstick, eyeliner, all this we cannot use in the IVF lab. Perfume free, we cannot use the perfume in the IVF lab. Okay, all these causes VOC release. See, this cardboard cannot enter the IVF lab. This plastic packaging cannot enter the IVF lab. This all this lipstick and all this cannot be done when you are working in the IVF lab. This perfume cannot be done when you're working in the IVF lab. Third hand smoke. What is third hand smoke? So if someone is smoking, okay, even when the smoke has gone, some particle will be attached to the body, to the hair, to your watch. That is the third hand smoke. Okay, that is also embryotoxic. Prevent contamination from third hand smoke residue on hair, cloth, clothing from smoking or smoke exposure from entering the IVF lab or art suit. Operator as a source of VOCs. Even operator can be a source of VOCs. So this should be considered during the risk assessment. Scrubs and equipment. See, scrubs, hair cover, shoe cover, all this should not be, no, it should be non-shedding. It should not shed things. It should be non-static and color stable. Even while washing, it should not leave color. Okay. Under condition of washing, drying, and sterilization. Detergent. Laundry detergent used for cleaning scrub. Laundry detergent used for cleaning scrubs and equipment should not release VOC. Even for detergent equipment, the scrub which we wear, if we'll use that is washed with the detergent, that should also not release the VOCs. See, this is a picture mnemonic kind of thing. Same thing, third and smoke. This operator is a source of VOCs. The laundry detergent used for cleaning and equipment should not release VOCs. This hair cover, scrub, and shoe cover should be non-shedding, non-static, and color stable under the condition of washing, drying, and sterilization. Now, photocopies and printer and computer. Photocopies and printer should be outside the lab. Okay, photocopies and printer, laser inject, emit VOCs, ozone, solvents, and toner dust. They should not be placed in the art suit. And if unavoidable, that should be placed in the negative pressure. Okay. A sealed cabinet under negative pressure. The cabinet should be sealed and it should be under negative pressure. Then computers. Desktop computers emit VOCs. Okay, desktop computer also emit VOCs and formaldehyde, particularly as they ages. Old computer secrete more VOCs. So we have to use minimum number of computer, and the computer should be switched off when not in use. And if we are using a new computer, it should be off gassed first. Off gas new computers by running them for 10 days outside the art suit. Tablets and smartphones. Stable is like we are taking phones inside the lab, and tablets, they are emit less VOCs. Okay. Risk assessment for equipment. Laboratory should conduct risk assessment regarding the use of computing and printing equipment in clean room environment to minimize VOC. We'll have to do risk assessment, that how much risk is there if we use computer and printing machine there. Okay, so basically we don't have to use if printers and computer inside the art suit, and we have to see the risk assessment for the equipment. Okay, thank you. Like and subscribe for more such content. Thank you.